Hello, we will be solving the line 75 today. So I'll be posting it as 6 to 7 videos where I'll be solving around 10 problems in each video. So the target is to complete line 75. So I have taken the line 75 from the Decode platform. So if you go to the Decode platform, you'll be able to see different sheets. One is line 75, Decode 150. Decode 150 is 75 from this plus 75 other problems. Similarly, Decode 250 is 150 plus another 100 problems. So now to start with, we will complete the line 75. So why I have chosen Decode platform is they have actually divided this into topics. So you have arrays and hashing, 2 pointers, sliding window. So we'll be covering it one by one. So today I'll be targeting to complete all these, and maybe we can even start with the 2 pointers. Yeah, so let's begin. So the first problem is contains duplicate. Let's read the question first. Given an integer array nums, return true if any value appears more than once in the array. Otherwise, return false. Okay, so we can see this example 1, 2, 3, 3. We have 3 which occurs twice, so we return true. Similarly, 1, 2, 3, 4. Nothing is repeated twice, so it's false. What if the array is empty? So we will be returning false if the array is empty because there's no number repeated. I think there's no other edge cases which I can come up with. Yeah, so this is it. Let's see the answer for this. So what I have done here is I create a set here. Why set? Because set helps you to find whether there is a duplicate in it. So what I do is I have a temporary variable, a set. Then I iterate through each number and check whether this number is already present in our set, the temporary variable. If it is present, so this one, as we are using a set, it is O of 1 time complexity only. Okay, if not, we add it to this set. So let us iterate this input. So first 1 is not there in the set. So let me show you. So temp is initially empty. Okay, then we check whether 1 is there in the temp, which is not there. So what we do is we add 1, then 2 is also not there, we add 2, 3 is also not there, we add 3. Then again the next 3 comes and we already have a 3, so we return false. Okay, similarly, if it is instead of 3, if it is 4, we just add 4 to the temp. And as the, return true here because you found it as duplicate. And after 4, this loop ends and finally you return false because this does not contain duplicates. So this was our first question. Okay, let's see the time complexity and space complexity of this then. What is the time complexity? Time complexity would be so we iterate through each number, so it is O of n, and all these other operations are O of 1 only, so we end up with O of n. And space complexity, we have a set which is containing in the worst case it will contain all the elements, so it is O of n. So this is my solution, O of n time complexity and O of n space complexity. Okay, so let's move on to the second problem, which is valid anagram. So what is an anagram? Anagram is a string that contains the exact same characters as another string, but the order of the characters can be different. For example, race car and car race. They have the same number of characters, but they are just jumbled. So that is anagram. So let's read the question. Given two strings S and T, return true if the two strings are anagrams of each other. Otherwise, return false. Okay, so two strings, if they are anagrams of each other, okay. Okay, so okay, so here we can see jar, jam. So the input is going to be two strings, and we are going to return either true or false. And it is also given that S and T consist of lowercase English letters only. Okay, so this is okay. So first thing what we can do is we can check the length of both and see if it is equal or not. If it is not equal, it is obvious that it is not an anagram. Okay, so we can return false here. Okay, and then what we can do is we can just get the counter, count the elements, and check whether the elements of string S and T are equal. So that's what I have done here. Counter of S equal to counter of T. So let's say what I'll just tell you what this counter for the first input will be. Okay, for counter of S, it's a dictionary. This will actually return a dictionary. Okay, so R, it will tell R to A to C race car to E1. That's it I guess. Yeah, so I mean you can even, I'll just print and show this as well. Print. Okay, just for this purpose I'm printing it above. This is not required. Counter of S. Okay, so let's run and see. R2, A2, C2, E1. So similarly, counter of T would also have the same these things. If you want, you can print and show. You can see it is the same dictionary. So the order is different, but the elements in the dictionary are same. So you return true. That's it. We actually don't want to print this. Let's submit this. Okay, so now let's look at the time and space complexity. For this, it is, as we know, each element is going to be picked and compared. So it is going to be O of time complexity will be O of length of S plus length of T. Okay, because we'll have to go through all those things. And similarly, space complexity is also the same, because we are storing all the elements, or probably it is O of unique elements K. So I will O of K. Worst case is again O of length of S plus length of T. So this was this. Okay, now let's go to the third problem. So this one I already have a longer video for this, where I have explained why each from brute force to the optimal solution of how to solve this. So you can visit that video. Okay, I'll just give you a short one. Okay, so here this is a brute force approach which I have done. For the optimized optimal approach, you can go and see the two-sum video. Okay, so now let's read the question. Given an array of integers nums and an integer target, return the indices I and j such that nums of I plus nums of j equal to target and I not equal to j. You may assume that every input has exactly one pair of indices I and j that is satisfied the condition. So this is one very important constraint or assumption. Return the answer with the smaller index first. Okay, so now we have 3, 4, 5, 6 and our target is 7, which is 3 and 4 added up gives you 7. So you return 0 and 1. Okay, I'll just give the optimal solution here. So in this case, what I'm doing is I'm having a dictionary to hold on to whatever I've already seen, whatever integers I've already seen. Okay, now what I do is I iterate each number, enumerate. I want to know its index because I'm going to store its index. Okay. See, if you have to just return the numbers, you can just go for a set. But as we need to return the indices, we are going for a dictionary here. So I have I and number, enumerate numbers. So now if num in temp return temp of num comma I. If not, okay, else temp of target minus num equal to I. So I have explained this one in detail in the video, to some video. So you can just go. I don't think we need to return anything here. So yeah. What is the time complexity of this is just O of n. Space complexity is also O of n. Okay, how? Or it is simple. We are iterating each number only once. Okay, and checking the dictionaries and amortized O of 1 time complexity again, and then we are just returning, or else we are adding. Here we are storing all the numbers, so the space complexity is going to be again O of n. So yeah, third problem is done. Next is fourth question. This is a medium question. Okay, so now here it's a group anagrams. So we just saw what an anagram is. Anagram is a string that contains the exact same characters as another string, only the order can be different. So now here we are given an array of strings, strs. Group all anagrams together into sublists. You may return the output in any order. Okay, so here now we need to group things which are same, okay, which are similar anagrams. Okay, so what we do, so here you can see act and cat are anagrams, so they are grouped together. I think it can be written in any order also. Yeah, so act and cat. Pots, tops, stop, all three are same words, so they are anagrams. Hat does not have any other thing, so we just return it as a separate list. Okay, so if the input is empty, okay, so let's see the constraints. Could be 1 to 1000. Strings of I could be empty as well, but string is going to have, they're going to be at least one string, but the string could be empty. It's all made up of lower English letters. Okay, let's see the solution now. So what we have here is, so what I do is I start with a dictionary here. Okay, so what we want is, what we are trying to create is actually for ACT, I wanted to hold act and cat. Okay, as you can see, my key is in sorted ascending order. Okay, I'm holding that as my key. Okay, similarly the next one, probably I'll just do hat. AHT will have hat. Okay, and OPST maybe, yeah, will have the remaining words. Okay, so this is a dictionary which we want to create. How will we create? So Anagrams is a dictionary which I am default dict list. So if you give it as default dict list, what happens is the key is not there. It assumes that it will just add the key. Assume that this list does not have this thing called as key. What it will do is it will just add an empty list as a value for a unknown key. That's it. So that is the use of using a default dict with list. Similarly, you can have default dict with int, float, and other things. Okay. So now what we are doing is, for simplicity, I'll just start with this one. Yeah, I'll just show you this one. Yeah. So what we are doing is, for S in strings, what we are doing is anagrams of, we are sorting the string. The sorted string will return you a list. So I'm just combining this list, and that will be the key, and I will append that string to this list. Okay, and then return it again. Okay, so if you do it this way, so that's what we were discussing, right? So the dictionary is ready. This kind of a dictionary will be there, and we just again to convert it back O of n. So it is just, this time complexity is going to be O of n. Why O of n? Because n is the length of the strings, and so we are picking each one. So it is technically O of n plus, okay, so this one, wait, n into k log k. Okay, n into k log k for the sorting one, n for this, plus again O of maybe n, actually probably m. M is smaller than n, so we'll just go with O of n into k log k. Because this is times complexity. Space complexity is, what are we doing? It is just O of n for our this thing, for the dictionary. Okay, now to optimize this, I don't want this k log k to be there, and given that strings of I is made up of lowercase English letters only, what we can do is, instead of sorting it, we can just go and have a dictionary of 26 characters, and this one will be the input. Assume that I have a word called as ABC. So what will this dictionary be? This dictionary C, it's not a dictionary, it's an array, so it will have 1, 1, 1 and 0, all other zeros, all other 23 characters of zeros. Okay, so now what we are doing, we are just counting each character. How are we counting? Count of odd of C, that is, for example, let's take, we have this string, the first character is A, so A minus A is the 0th element, so for 0th element we increment it, so which will have 1. Then for the next one is C, C minus A is O of 2, we increment that. Okay, so now the key becomes the tuple of count. Instead of sorting, you're just skipping sorting here. Now the time complexity is of n into k. So we have reduced it from n into k log k to n into k. that's it. Yeah, this is accept. So next question is top k frequent elements. Okay, let's read the question. Given an given an integer array nums and an integer k, return the k most frequent elements within the array. Okay. The test cases are generated such that the answer is always unique. Okay, so you may return the output in any order. Okay, so now let's see. First thing which we need to do is we need to create a counter. Okay, so for example, we have this example. Okay, let's take this example. Okay. So what it will be is 1 as 1, 2 as 2, 3 has 3. Okay. And what is the highest frequency ones? Frequency ones are 3 and 2. So we return 2 and 3. Okay. Similarly, 7, 7, k is 1, 7, 2. So we'll have as it is 7, 7. We will have 7, 2, and it is only we need only the top first element. So we return, we pop 7. So how can we do this? Let's see the answer. First thing, as I said, I'm just creating the counter. Okay, this is the first step for this. Next one, you can either create a heap and pick the maximum ones. Okay, but that has an advantage of going through the heap and popping each time. Popping from a heap is again log of k or n. So instead of that, what I do is we just create a buckets list. So what will this list be? Let me have the previous ones here. So we have created till this step. Okay, so now buckets is equals to we are going to create an empty list of lists till nums plus 1. So what can be the thing? What is the length of nums here? It is 2. Okay, so we can have the same number for n times. So what we are doing is 0 to for 0, 1 and 2. Okay, and what we do now is we just iterate through the dictionary, and here we can see that this is the frequency. So this is the number and this is the frequency. For frequency 2 we have 7. Okay, for remaining we don't have anything else. Okay, so now what we do is we are going to pop k elements from the back. Okay, so for frequency in range negative -1, 0 to -1. Okay, now this could have multiple numbers. Okay, so that's why they have given the test cases are generated such that the answer is always unique. So it is always given that if k is equal to 1, this will k is equals to n. Let's have k is equals to n. This will always have less than or equal to n numbers only. This one will not be having more than n elements for us to get confused to which one to pick. So the test cases are generated in a unique manner. It is created in that fashion. So we just add the 7 to our answer and return our answer when the length of answer becomes equal to k. Okay, so for this question also, for this example as well, let's discuss how it will be. So this is like 3, 4, 5, 6. So I need 7 lists. 3, 4, 5, 6, 7 lists. So we have 7 lists now. Okay, now for the first one, we add 1. For second one, we add 2. Third one, we have 3. And we know that k is equals to 2. So now we are iterating from behind. Okay, so we pick this, we pick the elements from this and append to the answer. 0, 0, 0, 1. Here you become 2, and which is equal to the k, and you return the answer, which is 3 and 2. So it could be 3 and 2 or 2 and 3. So that's why they have given your output may return you may return the output in any order. So we shouldn't worry about all those things. Yeah. This is also right. Okay. So let's go to the 6th problem. So this problem was not, it was a premium question in LeetCode, whereas here you can find the problem in LeetCode platform. Yeah. So encode and decode strings. The question is, design an algorithm to encode a list of strings to a single string. The encoded string is then decoded back to the original list of strings. Okay, so we need to they've given a list of strings. You need to encode it and find a way to decode it back to the same list. Okay, so now first, this is our input. Neat code, love you. Okay, how can we combine this whole string into this list of strings into a single string? One problem is I will not be able to use comma to separate them, because what if the string in itself has a comma? Okay, so if I use comma as my delimiter and create a new string, what will it be? Neat code, love you. Sorry. Okay, and now when I decode this back, what I will get is I'll get this, which is not equal to my input. Okay, for that matter, not just comma, the string can contain any UTF-8 characters. So it might contain any characters. Okay, so that is difficult. So we won't be able to use any delimiter. So what can we do? Okay, so what we can do is, let us first find the number of elements in each string and encode that in the string. For example, here it is 5. Then this one has 4, this one has 4, this one has 3. Okay, and then we use, we don't have to mandate, we need to use, we can use a delimiter here, a very known delimiter, because that is the way where we can know that this is the size length information. So let me assume I'm using maybe colon, and then what we do is we just copy the remaining ones without any delimiters. Okay, so now, oh sorry, my bad, it's E. Okay, now what we'll do is we'll keep on iterating till we find the colon. Okay, put those values in a 5, 4, 4, 3, all these things in a string, in a list. Okay, and then the first 5 elements, 1, 2, 3, 4, 5 is the first word. The next 4 elements is the second word. The next 4 elements is the third word. Okay, and the next 3 elements is the fourth one. Okay, now you may ask, why do we even need this comma? if you don't have this comma, how will you identify if it is a 12, if a word has 12 characters? Okay, how will you know whether it is 1 character, comma 2 character, or 12 characters in whole? So that is why we are having this comma, and the first delimiter could be anything but not a comma. And if this is not there, and assume that the first character is a number, if the string had 1 NE or something, how will you know where to skip? So that is why we have this delimiter here. Okay, so now let's see the solution. So what I'm doing is just as what I just explained. So I have an empty string as my result or the answer. For every string, what I'm doing here is I am concatenating the length of the string and appending a comma to it. Okay, after I find all the sizes, that is, after I find all these elements, I'm appending a hash. Okay, so here I have used hash as a delimiter. We can also use colon. Okay, yeah. So then what am I doing is I'm just taking all the S and concatenating them. Okay, and then okay, this is not required now. Okay, let's just have it for our understanding, printing them. Then we return the result. Okay, let us run and see. Yeah. So now this, what did this string become? It was encoded into 4 4 4 3 4 4 4 3 with a colon. It could even be hash, any delimiter which is not a number or not a this thing, not comma, not comma or not number. It could even be a letter also as well. Could be an alphabet as well, but yeah, I would prefer going for a symbol. And then you have need code love you without any spaces. So this is this thing. Now let's see the time complexity of just encoding. This one is O of n. And this one is again O of n. So this is O of n. Okay, now let's the space complexity is going to be O of n plus k space complexity, because k is the length of all strings together. For example, here we get, so this one, so this is n and this is k, so it's n plus k. Now let's decode this. So what and all we want? So strings is going to be our answer, sizes to find these numbers. Okay, so first I is equals to 0, current equals to 0. Okay, if SFI not equal to the delimiter, till then I need to keep on doing this stuff. If S of I not equal to comma, what we do is current equal to current. So this is for the case where you get 12. Okay, so 2 is not equal to comma. So what we do is 10, current was 1 into 10 plus 2, so that is 12. So to change that, it is kept. If it is comma, what we do is we just change sizes dot append current. Okay, and current equal to 0. Okay, for example, if it was only for the 1, would have been 0 into 10 plus 1. So that would have made it as 1, and for 2 it would have come and it would have made it as 12. Okay, and then we go for a I plus equal to 1. So we keep on doing it until we find the delimiter. Okay, so then when we find the delimiter, that's when we have already found all the sizes. We have appended everything in the sizes array, strings.append. So now what we do is, from this point, from n, the first 4 elements is going to be the first string, then the next 4 elements, then the next 4 elements, the next 3 elements. So s of j equals to, so strings.append s of j to j plus size. So if it is 0, 0 to 4. So this will be an this is so it is like this. So this element will not be included. Okay, so that's how we do. And similarly here as well, we have the same O of n plus k time complexity, because we are going through each and everything. O of n plus k is the time complexity, and space complexity is also O of n plus k, because we are storing the strings as well as the sizes. So it is again O of n plus k. So let's submit this. Yeah, this question is also done. Okay, next is a very interesting question. I'll get this answer from here, because this does not use yeah. So products of array except self. Given an integer array nums, written in an array output where output of I is the product of all the elements of nums except nums of I. Each product is guaranteed to fit in a 32-bit integer, so we don't have to worry about overflowing and other stuff. And could you solve it in O of n time without using the division operator? Okay, I mean, if you had to use the we can easily do it with O of n using the division operator. Like, you just iterate over the numbers. Just a minute. This one is without using the using the division operator. Okay, so let's just complete the examples as well. So 1, 2, 4, 6. Okay, the first element has to be 2 into 4 into 6, which is 8 into 6, which is 48. Second element has to be 4 into 6 into 1, which is 24. Third element has to be 2 into 6 into 1, which is 12. And this last element has to be 1 into 2 into 4, which is 8. So that is what we want to do. Okay, we can first, let me tell you how to do it with using the division operator. It's simple. You just find the product of all integers and count whether there is 1 zeros or 2 zeros. Okay, if there are 2 zeros, the whole output is going to be all zeros. If it is just 1 0, then if that element is not 0, okay, you just append it as 0 wherever the element is not 0, and for other places you append it as the product without considering 0, or else you just divide the number from the product. So this is one way of solving it, wherein you don't use where you use division operator. So now let's see the answer, see a case, a solution where we don't have to use our division operator. So what I'm doing is I'm creating a copy so that I have the numbers as well, and another copy. So you necessarily don't need a copy. You can even have it as, like, say 0 into num of length of num. You can even have it this way. Okay, so first what I do is I have a variable prod, which is the same as the input. Okay, so let's assume we are considering this case. Okay, yeah, and I have a variable pre. So this is just my multiplication constant, because yeah, that's what we are going to do. First, what I do is I come from back, I iterate from behind and change each input based on the value. Okay, so what we can do is previous is equals to previous into nums of I. So we are at 6 now. Okay, we are doing a reverse operation, length of nums minus 1 till minus 1 with a step size of minus 1. So we are going in reverse now. So what our previous will become is 1 into 6. So it is 6 now. Okay, and the product of I has to become previous, so which is 6 again. Then we go again, we are at 4, 6 into 4, 24. So 24 here, and then we go again, it becomes 48, and then we go again 48. So the first thing which we are doing is we are computing our maybe call it as products from behind array or the suffix array, maybe, I don't know. So we are creating this array where we are calculating everything from back. Now this is ready. Okay, what we are doing is then we are resetting our product again, and this time we will come from forward. Okay, so we know that this element is the 48 is the product of the I plus 1 to so on. So now we will start computing our product from front. Okay, so the product was 1. Okay, so now what we'll do is this answer has to be 1 into the product of I plus 1, that is the remaining elements. So here what we are doing is we will be computing the products till I minus 1 using brief, and we already have our product of I plus 1 stored. Okay, so using these two, if we multiply these two now, we will get product except self, right? So now it is 1, product was 48, so we will just have it as 48. Now nums of I you had, okay, I'll just write nums of I again. Nums is 1, 2, 4, 6. Okay, now our previous again 1, because we are multiplying it using nums of I, previous 1 again, but our I is here. Okay, for this element it is going to be 1 into 24, the next element. Okay, for this one it is going to be 4 into 6, which is 24. Wait, oh no, sorry, it's going to be 2. So 2 into 6, which is 12. Okay, here we don't have I plus 1, so what we do is we just add whatever was there in previous. That's it. Okay, so now this is going to be our output element. That's what we are doing here. First, we are keeping a duplicate copy to compute the suffixes for I in range length of nums. So we are doing a reverse iteration. For every time we consider the current number and we update our product of I, and then we have previous, we reset the previous to 1, and now we find the prefixes. We keep on finding prefixes, we ignore the current element, and if it is I plus 1, I mean this is for the last element. For last element it's just whatever was computed till the prefix sum, the prefix product, which is our brief. Okay, so this is our product except self. answer. So for this, it is O of n plus O of n time complexity, which is O of n again. Time complexity is O of n. And space complexity is, if we ignore the space it takes to store the answer, it is O of 1, or else it is O of n. If you are considering the space, the output space, so of n. Anyway, we need to return it as a array, so I think you can consider this as O of 1 itself. That's it. So yeah, you can even use it as, you don't have to copy it from nums, not necessarily. The numbers does not matter here, but we need to preserve numbers, so that's why we are creating a new product. Yeah, okay, so this question is also done. Next is longest consecutive sequence. What is that? Given an array of integers nums, return the length of the longest consecutive sequence of elements that can be formed. Okay, a consecutive sequence is a sequence of elements in which each element is exactly one greater than the previous element. The element do not have to be consecutive in the original array. Okay, it does not have to be consecutive in the original array. Okay, so here what they are telling is you must write an algorithm that runs in O of n time. Okay, so this is our input. Okay, here we can see that, I'm just sorting it for myself to see it. Here we can see 2, 3, 4, 5 is the length of the consecutive array, so our answer is going to be 4. So the input is going to be a 1 in list, and we need to return the length of the longest consecutive sequence. Here it is going to be 0, 1, then again 1, 2, 3, 4, 5, 6. So 0 to 6 is 7. It will be our answer. So for this, what we are doing is, the repetition does not matter, because the consecutive, it just have to be there. That's it. The order does not matter in the original array. So having 2 ones is like you just skip, you just assume that it's some other number, you just skip it. That's it. So what we do is we create a set first. So this will help us ignore the unwanted numbers, and it can help us reduce the time complexity as well, because you never know, there might be a lot of duplicates. We don't want to work on duplicates. So num set equals to set of nums. So now what will our set hold? Let me start for this question. It will hold 0 to 6. This one will not be there. The set will not have this 2 ones. It will have 1 1. Okay, and our answer is 0. Okay, initially let me assume that our answer is 0. Okay, because the length could also be 0. Okay, now we are iterating for each number in num set. If num minus 1 is not in the set, that is, I start from 20. Okay, it is a set. It is not going to be ordered, so it can be anything. So if I start from 20, and if 19 is not in the set, so this 20 will be my starting point. Correct? So num minus 1, not in num set. What I do is current equal to 1. Now I keep increasing my current until I find a number which is greater than 1 than my current number. So while num plus current is in num set, current plus equal to 1. So assume we had 0, we don't have minus 1 in the set, so 0, for 0 the current is 1. 0 plus 1, which is equal to 1, is there in the set. Okay, so we increase current by 1. So I'll just write it here. Current was first 0, okay, and then I made, we found 0, minus 1 is not there, we come inside, we have current equal to 1 now. Okay, while num plus current in num set, that is 0 plus 1 is there in the current set, so I make it as 2. then 0 plus 2, 2 is in current set, so I make it as 3, then I make it as 4, then I make it as 5, then I make it as 6, then I come to 7, where I find that there is no 7 in the list, and this while loop breaks, and current 7 is greater than answer, so answer will become 7. Okay, and then what happens is we go to 3. Okay, 3 minus 2 is there in the set, 3 is already consumed, so we skip all the remaining ones and we return the answer. Okay, so now let's consider the time complexity. Okay, this might look easier to find the time complexity, but it's not, is it? Okay, what we are doing here, this might look like an O of n square time complexity because you are doing a nested loop. There is a while inside the for, but as I said, when you come to 3 here, in this case, you will just skip 3 because you have already considered 3. So no matter what, you will only consider each element once in this, both for loops together, you will consider it only once. So the time complexity will remain as O of n. Space complexity, we're converting it into a set, so it is again O of n. Okay, so let's run this. So we have successfully completed this. Let's go to the next problem. Next one is an easy one. Valid palindrome. Okay, so we are just finding it as a palindrome, but with some twist, I guess. Yeah, given a string s, return true if it is a palindrome, otherwise return false. Okay, what is a palindrome? A palindrome is a string that needs the same forward and backward. Okay, that reads the same forward and backward. It is also case insensitive and ignores all non-alphanumeric characters. Okay, it is case insensitive. So this capital W and this small w are considered to be same. Okay, and it ignores all non-alphanumeric characters. So this question mark, the space in between, everything is ignored. So alphanumeric characters consist only of letters from A to Z, and 0 to 9. Okay. So what we can do is, we can remove all these, we can make it to lower, remove all the spaces and other non-alphanumeric characters, we remove it, and then we reverse it and compare both the strings to verify if it is a palindrome or not. Okay, so that is one way of doing it. Tabacat is not a this thing, not a palindrome. So S is made up of only printable ASCII characters, it seems. Okay. So now what we can do is, let me maybe use this one. Okay, let me go and paint maybe, yeah. Cat. Okay. For simplicity, what I will do is, I'll make this also as a B. So that it remains a palindrome. You can use a two-pointer approach. Okay, my one pointer is here, the other pointer is here. Okay, for example, let us even use let me have a question mark here. Okay, so it starts here. What I can do is, if I keep increasing my left pointer until I find a alphanumeric value, and similarly I keep moving right until I find a alphanumeric value. So this one is an alphanumeric value, so we are here. This one is not an alphanumeric value, so we move it from here to here. Okay, now both these values are same. If in case at this point the values are not same, we return as not a palindrome, so it is a false. Okay, But luckily here we have both the characters are same. If both the characters are same, what we do is we again start to find the next alphanumeric character which is there in both sides. It's same. Then again we come here. Here, previous case it was B and C. It would have returned a false, but it is not B and C. It is BB here. So we keep moving. Here we see that both are not alphanumeric. So again we keep moving. Okay, at this point both my left and right pointers come to a single point, so they both are same. And if I keep moving anymore, my left will no more be less than my right, so I break here. So we are technically using a two-pointer approach to find this. Okay, let's see the code. Yeah. Okay, so I have, as I said, I have left and right pointers, which is 0 and the last element. While left is less than right, and here what I do is left has to be less than right, and s of left, if s of left is not a alphanumeric, then I increase left. So that's what I said. I keep on increasing my left pointer until I find a alphanumeric value. Similarly, I keep on moving and to find a alphanumeric value in the right side as well. Now, if both are not equal, then I return false, and I also increment. If they are equal, I increment and decrement both, and again the loop keeps on going. And if I've completed and this loop exists, that means it is a palindrome and we get a palindrome. So this was a pretty quick, easy question. Next one is threesome. Yep, threesome is a very interesting question. So if you have solved twosome, you know that if you see my twosome separate video, I would have discussed a solution for sorted arrays. So here we are using the same approach, two-pointer approach for a sorted array. That's what we are using it here. So threesome is nothing but you are given an array nums and you need to return the triplets nums of I, j and k such that they are all equal to 0. So there what we get is we need to return two numbers and we have a target. We have to find two numbers such that they add up to the target. Here we need to find three numbers such that they add up to 0. Okay, the output should not contain any duplicate triplets. You may return the output and the triplets in any order. Okay, so here it's not required the solution. There's only one unique solution. There could be multiple solutions as well here. So let's see the answer. Maybe we can discuss this one. Yeah. So as a first step, here I don't have to return my indices, so I do not store the index of the numbers and I sort as it is. If you have seen my twosome video, what I would have done is I would have created a tuple of index and the number, and then I would have sorted so that I can preserve my index. Here in this case, we don't need to preserve the index because the index does not matter. We just need to return the numbers. Okay, so I just sort it and I keep answer as a set so that I don't have to worry about duplicate values. I just add it. If it is duplicate, it just ignore. While returning, I would just return it as a list. I'll convert it into a list and return it. Okay. So now for I in range length of nums. So now what we are going to do is we have a sorted list. Okay, let's assume I take this as my input. Okay, this is my input. Okay. So when I sort this, what it will be is -1, -4, -1, -1, 0, 1, 2, am I right? 3, 4, 5, 6, 3, 4, 6, yeah. So what I do is I keep this as I. Okay. Then find j and k from this list, from here to here, such that so j, this is the same thing, I plus j plus k equal to 0, nums of I plus j, nums of j's, okay, the value at that in this, okay, and I know I, so I need to find j plus k equal to minus I. So that's what we are looking to find here. Okay, so initially what, and then we move I and then find from the remaining, then move I, find from the remaining. Okay, so from this part we'll do, then we keep I here and then we do this part and so on, okay, until we find all solutions. Okay, so if you have seen my 2-sum answer, this will be very, very easy. Okay, so now let's see the solution itself. So here, this is my first loop for I in range, this thing, okay. If I is greater than 0 and nums of I equal to nums of I minus 1. See, if I is greater than 0, I'm going to continue. Why? Because if I is already greater than 0, there is no way that two numbers from values greater than I'll be able to, which are added together will give a negative number. So if I is already, because I is, as we can see, I is always the smallest one. If I itself is positive, j and k are obviously going to be positive and we will not be able to get a negative number, so we won't be able to get 0 after that point. So after here till 0, okay, when I reach I here, that is when I can stop. I can probably even break there, okay, maybe to combine I've just given it as continue, but I can actually break and come out of the loop. And if nums of I equal to nums of I minus 1, if I've already considered this in the previous, for example, these two are same, okay, so in the remaining part they are going to yield the same results which I have already added to my answer, so I can just continue in this case. Okay, so now for j, what I'm doing is, this is the interesting part. If you've seen my 2-sum, this would be very easy. So here it is j, here it is k. Okay, so j and k. So now what we do is, if minus 1 plus 2 is 1, which is still less, so what I do is I increase my j. Okay, j is already equal to the previous one, so I keep increasing my j again. Zero plus 2 and 4. I need to increase. So this one, I'm not able to get any value by keeping minus 4 as my I. Okay, because if I increase it more, it'll come here and the loop will break. So what we do is we increase our I now. So this is our I. Okay, so, and now j is here, k is here. Minus 1 plus 2 is 1. So this is a valid answer. Minus 1, minus 1. Okay, when I comes here, I just continue because it was the same previous one. I don't want. I is 0, which again cannot be. J is here, k is here, so there's no answer for this. No, there's only, and when I come here, I just break and come out. So that's what we are doing here. Oh, minus 101 was also one of the answers. Okay, I missed it. Okay. So now, if nums of I plus nums of j plus nums of k equal to 0, then that is our answer. So we add all these values to the answer and increase j by 1 and decrease k by 1 and keep on doing, like skipping whatever is not required. Similarly, if it is less than 0, then we need to increase j value. If it is greater than 0, we need to decrease the k value. So that is the answer here. And as you can see, I can even do it this way and show you. It will give the same value, same answer. No? Oh, sorry. Okay, so so this is just I greater than 0, just to ensure that it does not break my any array index problem. So this could also be one of the one. I mean, this will help you to break earlier. That's it. Yeah. This is one more solution. So yeah, here if we see the time complexity and space complexity, the outer loop is 1 and we have a while loop here. So this is O of n square complexity, and space complexity could also be O of n square because we are storing all those values. We could maybe skip storage and we can assume it to be O of 1 itself. So it's O of n square comma O of 1. Let's get going to the next question. Container with most water. Okay. You are given an integer array heights where heights of I represents the height of the ith bar. You may choose any 2 bars to form a container. Return the maximum amount of water in a water container can store. So this also I'll again go with a 2-pointer approach. Let's try, like I'll just try screenshotting this and putting it in my paint. Yeah. So now assume that I have 2-pointer approach. So 1 pointer is here, 1 is here. What I do is I find the area of this area, that it's area, right? Yeah, it is actually area. So here, from here to here, what is the maximum? I'll have an answer. Till now my maximum is 0. Okay, so we have we draw this. Okay, so now it is 1 into 1, 2, 3, 4, 5, 6, 7. So the area has become 7. Okay, and what we can do is we can increment the place which is the site which is of least height, because our aim is to maximize our area. Okay, so what I do is I skip this to here. Okay, now this is 6 into 6, 1, 2, 3, 4, 5, 6. Yeah, 6 into 6, which is 36. Okay, if it is less than this value, I won't change it. I won't replace that value. Okay, now this one is the smallest. So what we do is we remove this here to here. Now this is our height. Okay, which is 5 into 5, 25. Here 25 is less than 36. So we will not update our answer. Okay. Seeing here, this is our minimum. So we come here. Okay, here and here it is this big. So this could be our answer, maybe 7 into 1, 2, 3, 4. Unfortunately, no. 7 4s are 28. So this is still smaller than 36. So that's not our answer. I don't think anything else could be answer. 36 is going to be answer. Yeah. Probably that's why they have actually highlighted it. Oops, sorry. Both are equal. Both are equal. So you can choose any one. Okay, by default, let me assume I am choosing the left one. Here it is 2 into 1, 2, 3, 6. Again, we remove this fellow, put it here. It is 5 2s are 10. Again, we remove this, put it here, and it is 4 1s are 4. So we know that it is 36 is the answer. So it's very easy question. So left is 0, right is the length of heights minus 1, answer equals to 0. While left less than right, area is equals to minimum of heights of left comma heights of right, whichever is minimum, into the right minus left, so the width. So in this case the minimum would have been 1 and this was 7, right? Yeah. So that would be the area. If area is greater than answer, as we saw, 7 is greater than 0, so we made it as 7. And if heights of left is less than heights of right, then left plus equal to 1. Else by default I'm doing right minus equal to 1. The case where both the heights were equal, right? For this case. So by default I'm doing it right minus equal to 1. Okay. Yeah, you can do it either way. You'll get the same answer doing it either way. That's it. So the time complexity for this is O of n and space complexity is O of 1, as we are not storing anything else. So let's run this. Yeah, so this is also done. I've already done some wrong answer for this question. Yeah. Next question is best time to buy and sell stocks. This is a very easy question. You are given an integer array prices, and prices of I is the price of neat coin on the ith day. You may choose a single day to buy one neat coin and choose a different date in the future to sell it. So it has to be you buy on one day and you choose to sell it on a future day only. Return the maximum profit you can achieve. You may choose to not make any transactions, in which case the profit would be 0. Okay. So in this case, if I buy it on 10, I don't have anywhere to sell it because there's no way I get a profit. So if I sell it, I will incur only losses. But whereas if I buy on 1 and sell it on 5, sell it for 5, then I have a $4 increase. Or if I buy it on 1 and sell it on 6, I get a $5 increase. If I buy it on 1 and sell it on 7, I get a $6 increase, and that is my maximum one. So what we need to do is, we need to buy it when the cost was minimum till date, and I try to sell it every day and calculate my profit and see here you can see in the front the next day's values as well. So you can just keep on going and sell it on the maximum profitable date. Okay, so what we do is we need to find the minimum so far. Okay, so we always buy it on the minimum day and sell it on the maximum day. Minimum day to the left is more important. Yeah, so minimum so far is price of 0 is minimum so far, answer equal to 0, and we start iterating from 1. For I in range 1 to length of prices, the gain would be prices of the current day's price and the day when I bought. Minimum so far is the day where I buy my stock. Okay, so current is equals to prices of I minus minimum so far. In this case, everything will be a negative gain and answer will not be updated at all for 10. And then we have okay, and if prices of I is less than minimum so far, so 1, we are at 1, minimum so far will become 1. Okay, and then we keep on doing this loop, and then we find it as 1 and 7. If you have to return the indexes, maybe you need another variable to store the index and store the answer, etc. That's it. So let's run. Okay, so let's discuss the time complexity and space complexity. Here just we are iterating it n times. it is O of n, that's it. And space complexity is, we are not storing anything other than the minimum so far, and so it is going to be O of 1. So yeah, so that's it for today. Please let me know if you found this easy and understandable. So the main reason for me to create this video is to just maybe put it in your ears, go for a walk, and you keep understanding the problem. So this helps in revising the concepts for me. So that is the main purpose I'm creating these videos, and probably it might be helpful for someone just like me. So I'll be completing the remaining questions. So today I think we have completed around 12 problems. 3, 4, 5, 6. Yeah, we have completed 12 problems today. Probably I'll be doing like 10 to 12 problems every day. So we can complete it in 6 to 7 parts. So this was part 1 of my blind 75 videos. Please do like, share and subscribe. Thank you so much.